Well, time to move on. And Katie, I think you're here somewhere to talk about some beautiful astronomical images after honoring a beautiful, inspirational woman. So, Katie, what do you have for us tonight?
Oh, so there are some beautiful images to share with you. This first one was taken by Blake Estes, who used to work at Griffith Observatory, and this is comet Pan-STARRS C 2017 K2. And this comet just made its closest approach to Earth on July 14th, which was 168 million miles beyond the orbit of Mars. And this is the lovely full moon over Griffith Observatory from July. And then these next set of images I was lucky enough to head to a few national parks this past summer. And this is the great prismatic spring of Yellowstone, which was just incredible, all of those colors. And then also from Yellowstone, this is the canyon with the lower falls, and you can see a rainbow in there, which was just beautiful. This is a sun halo right behind the clouds. You can see it there. And another rainbow. This one is from the Rocky Mountain National Park. And this is a recent image. This was a storm over Staten Island taken by Alexander Krivenishev, who gives us beautiful images. And this was actually taken yesterday evening. This is an incredible sunset from Moab, Utah. And then this next image is a sunset taken inside of Griffith Observatory from our camera obscura. This was taken by museum guide Laura Smith. And you can actually see the sunset visible through the camera obscura inside the building from mid-April through late August. So this is a really cool capture that she got. And then I was able to see some incredible wildlife. This is from Zion National Park. This is actually the California condor from Angel's Landing. And in 1987, the condor, there were only 27 condors left in the wild. And the population has been increasing and has reached over 460 with only 170 wild ones in California. So this was something really incredible to see. And then some beautiful bison. This is from Yellowstone National Park. And then a couple of my favorite images. These are bighorn sheep. And then we have a pika. This is from the Rockies. And pika they live above the tree line. So it was really cool to spot one of those. And then we've been having a spike in noctilucent clouds. This is taken by Daniel Fisher in Germany. And I've been told he watches All Space Considered sometimes. So it was really lovely to get this image from him. And if you look at this graph here, you can see the red line is 2022, the noctilucent cloud frequency, and the gray area is 2007 to 2021. And one of the reasons for noctilucent cloud occurrences like this are rocket launches, actually. So the black line there are rocket launches. The red line are the cloud frequency of noctilucent clouds. So when rockets launch, the plumes of water vapor are carried by the wind toward the polar mesosphere, and they become raw material for noctilucent clouds. So that helps to increase. And then we'll just show some of the beautiful images captured by some people all across the world. This is from Oliver Schwen. And then he also sent me this other colorful image, which is just beautiful. And then we have some noctilucent clouds over the Eiffel Tower in Paris. And this image here was taken by a cosmic ray balloon. This is actually the Oak Fire, which was in Yosemite National Park, but the cosmic ray balloon was launched for scientists to research a geomagnetic storm. And it turns out that cosmic rays have actually been down. They come from deep space, from things like supernova. And the gray lines here they show the solar cycles and the solar minimum we can see there. And as solar cycle 25 begins, as we're reaching maximum, the cosmic rays are going down. And that's actually because when the solar cycle is at its maximum, the coronal mass ejections and the strong magnetic field actually wipe away those cosmic rays. And then this lovely image is actually of the shadow from the Earth in between the SDO Solar Dynamic Observatory and the sun. We are in the solar eclipse season in space, and this happens twice a year. So that's a really cool image. And on to some solar system weather. This was a coronal mass ejection that happened on June 30th on the far side of the sun. So nothing coming toward Earth from this one. And then some incredible sunspots that we can see from this past month. This one was 3053, and that's 48 hours of development. And this sunspot actually has two dark cores that are wider than our Earth. And then this next one you see here kind of in the lower left of the image is 3055. And this is stretches more than 100,000 kilometers from end to end and more than a dozen dark cores. So lots of solar activity happening. This one was taken from David Pinsky, who's a museum guide here at Griffith Observatory on July 15th. It's a sun filament, which is turning into a prominence. And also on July 15th, if you look right in the middle upper of the image here, you can see what they call a canyon of fire that opened from the sun, which is a dark filament of magnesium. And the canyon stretched diagonally across the video. If you can see it there, it was 20,000 kilometers high and 10 times as long. And then this is from July 21st. This is a solar tsunami from sunspot 3060, which exploded in the early hours of July 21st, and that produced a C-class solar flare. And a tsunami is the shadowy shock wave seen racing away from the sun. This actually caused the US Air Force reported a type 2 solar radio burst from this. And also from July 21st, there was a coronal mass ejection, which you can see there. And there's actually another faint halo, full halo coronal mass ejection. And that one was launched from the tsunami. And then finally, this was taken recently by museum guide David Pinsky. This was a huge solar prominence from August 3rd. And with all this solar activity, we get some incredible images of Aurora. This one was from Mary Beth in Michigan. Some beautiful, beautiful colors there. And this was taken July 2nd. And then a couple from Robert Snatch. And this was a crack in the Earth's magnetic field on July 7th. And the crack stayed open for 14 hours, pouring solar wind in and produced a long-lasting G-class geomagnetic storm. And Robert said this is the first aurora he's been able to capture in a very long time. Those are some beautiful images. And then one more here from Mary Beth, which I just thought was incredible. This one is from Michigan as well on July 22nd. And then the Sophia telescope captured some of the southern lights. And this is a shortened and sped up video here of the incredible aurora captured from Sophia. And then I'll just leave you with a still there. So a lot of solar activity and some incredible images. And that's it for solar system weather.